All right, we're back. We're on page 5, notes 1, Calc D, doing multivariable stuff. We're talking about projections and components. So component, I find myself finding that more often than the projection, but let's see. We're going to do this by hand. So, and use proper notation. All right, we got this. So we want to find the component of B, I guess, along V. All right, so I know there are two different ways that I can think about that. One is I'm going to do B dot V. So V is like the floor, it's the direction. So I think of, because it's like the floor, it's going to end up in the denominator. That's like how I think that. Or the magnitude is going to end up there. So then we can calculate this. So that's going to be 2. So I'm doing, what am I doing? I'm doing this times this. And then, well, not like the component part, but you know what I mean, hopefully. And then this and this. All right, so that's 2 and then -2. All right. And then 6 over the magnitude of V, right? Which is 1 plus 4 plus 4 is square root of 9. Maybe I'll write more. 1 plus 4 plus 4. So I get 6 over 3. So I actually just get 2. That's interesting. So what is that? That is, if I draw B and I draw V. So I usually draw V so that it's like longer, just so it like works out. And then I put a light source up here somewhere that's going to be green because it's the color that I have. That light source is going to cause a shadow, and the shadow, in this case, is going to be 2 units long. That's basically what this means. Now what I want to do is I want to find the projection. So the projection is the actual vector, not just the length. It'll be the actual vector. So the projection, projectors, like the light source is kind of a projector, is going to be the component, which we just found, 2 times a unit vector in the direction of V. So that's going to be 1 over 3, 2 over 3, and 2 over 3. So that's going to be the vector 2/3, 4/3, 4/3. Okay, so what I'm going to do is I'm actually going to do this by hand, and then I'm also going to do it on the calculator just to, like, I don't know, see if I got it. So let's do the other way, right? So it would be the component of V along B. So now B is the base, and let's see what we get when we do that. So it's going to be V dot B over B, magnitude of B. Really got it. You can't be as casual about that as I am. The dot products are going to be the same, right? So we're still just going to get 6. So 6 over, but then we need the magnitude of B this time. So that's going to be 4 plus 1 plus 9. So 14, radical 14. And I'm not going to rationalize that. Part of why I'm not going to rationalize that is when I find the unit vector of B, it's going to be all these things over radical 14. And when I multiply, the radicals kind of disappear. You will find that that is a thing that happens like all the time. So the projection along B of V. So B is the base, V is the one that's up there. You got your projector that's pointed down. You're going to get the shadow of V along B. That's what's happening. So we're going to get 6 over root 14 times the unit vector of B, which is 2 over root 14, -1 over root 14, and 3 over root 14. So overall, we get the projection of B along V is 12 over 14. Not going to simplify. -6 over 14. Still not going to simplify. And 18 over 14. I mean, maybe I should simplify that, but I'm not going to. So is there any like relationship between these two projections? I don't really think so. I don't really know. I don't think there is. I mean, like looking at them, I'm not seeing like, oh yeah, this and this and this. I'm gonna try this on the calculator, and then I'll probably just like cut it and then come back and do the next one, which is essentially the same problem, except it's like, I think the next one's actually like, no, it's by hand and by calculator. So like, I'm gonna come back and do it. All right, let's see. So V is going to be the vector 1, 2, 2. and B is going to be the vector 2, -1, 3. All right, so for the component, I want, so I'm going to do the component of, I don't know, I'm not going to name it. I'm going to do the component of B along V, right? So that's going to be dot product. So menu 7, C, 3. Dot product of, so I'm doing the component of B along V. So B and then V has to be a unit vector. So I'm going to do menu 7, C, 1 of V, and we get 2. And then to find the projection, it's going to be that answer times the unit vector of V. And we get 2/3, 4/3, 4/3. Nice. Now to flip it up, and you can see how you could easily define these as functions if you wanted to. And I think at the bottom of the notes, it tells you how. So this is annoying because it rationalizes it. Is this the same as 6 over the square root of 14? It is. All right, so we're in shape. And then this I want to take and multiply by the unit vector of B in this case. So you use the unit vector thing twice. So you get this 6/7, -3/7, 9/7, which is exactly what we got, but we didn't simplify it because I hardcore was avoiding that. Let's go back to the notes and you can see what we wrote, and then I'll come back in the next video and do some more. I don't know what else is on this page. Oh, it's just like one more thing. All right. So in the next video, I'm going to do another example. So if this wasn't enough, I will see you in that one, and we'll be doing more. So see you there.